So my teacher project for this week is the division of fractions using the invert and multiply method. And lots of times in schools, students are taught to memorize this method in little tricks like don't ask why, just invert and multiply, or change or leave change flip, or just invert and flip, or use reciprocal and multiply. So today though we're going to talk about why that works and why that makes your life so much easier than trying to divide two fractions, which is really pretty tricky and icky. But I'm going to start with dividing two whole numbers. So say we have 6 divided by 2. Most of us can do that pretty easily, but for example, if we had 6 oranges and we had 2 people to divide them among, we would ask how many oranges would each person get, and they would get 3. There's another way to do this, and it goes back to the relationship between division and multiplication. So if we had 6 oranges, we can also do the same problem by multiplying those 6 oranges by the reciprocal of 2, which is a half. So instead of dividing, we can multiply the 6 by a half. And look at that, we still get our answer of 3. But that's going to be a really important piece in why the division of fractions we can flip and multiply. So that one's pretty easy. What if though we had 2 and we want to divide the 2 by a quarter? So we have 2 oranges and we want to divide those 2 oranges by a quarter. So we might be able to look at that ourselves and know that we're going to get 8 pieces if we divide it, if we're really good at division. But we also could know by using our one example. If we knew our leave, change, flip, so we're leaving our 2, we're changing our multiplication, or division to multiplication, and we're flipping that quarter into just 4. And look at that, 2 times 4 equals 8. Great. Those are 2 pretty easy ones to look at. But what if we had 7 and we want to divide that by 8/9? Wah wah, that already looks pretty gross. We don't want to do that, right? So, what we can do to make our life easier, since nobody wants to divide a number by 8/9, that looks awful, is we can figure out how to divide a number by 1. So that's basically why the invert and multiply work, is because it makes our life easier. And it's much easier to divide a number by 1 than to divide it by a fraction. So we could take this 7 divided by 8/9 here, and we can make it into a compound fraction. So just writing it differently. So we can take our 7 divided by 8/9. Still, our life is not easier. Still looks pretty icky to me. However, we want to get rid of this, right, by making it into a 1. And we do that, and we already know that. We can do that by multiplying that number by its reciprocal. So we're going to multiply the 8/9 by its reciprocal, which is 9/8. And then we get that lovely little 1. We love that one. That looks great. However, we can't change our problem. We can't change the value of it. So we're going to need to take that 9/8 and bring it up to the top too. So we're doing the same thing to the top as we're doing to the bottom. So we're going to now multiply that 7 by that 9/8. And that's going to get us our number. And our 1 at the bottom is just going to cancel itself out. So we could do that multiplication, but I'm going to save that. I bet you guys could do that pretty easily. let's take now two fractions and divide them by each other. So how about 3/4 divided by 1/2? So again, ew, who wants to divide a fraction into another fraction? That doesn't look any fun at all. So let's take our 3/4 and make that compound fraction or super fraction, and we'll write it exactly the same, divided by 1/2. But let's get rid of that 1/2. That looks icky to me. So we're going to take that reciprocal of 1/2, which is 2/1, or just 2, and we get 1 times 2 equals 2, 2 times 1 equals 2. Look at that, we love that number. That's the number 1, that's easy to work with. But of course we need to move that reciprocal, that 2, up to our top so we don't change the value of our fraction. And we have 3 times 2 equals 6, and 4 times 1 equals 4. So 6/4 divided by that lovely little 1 there that we can just get rid of. And we have 6/4, or 1 and 2/4, or 1.5. Great. Let's try one more. Let's try, I had one written down. Oh, here's a good one. How about 3/7 divided by 1/5? Again, that doesn't look fun. We've already been studying division of fractions, and we know it's not an easy thing to do. But we multiply by fractions much easier, don't we? So we're going to take 3/7 divided by 1/5. Time to get rid of that denominator here by multiplying by its reciprocal. 1 times 5 equals 5. 5 times 1 equals 5. Look at that. A 1. We love it. But of course we got to take this fraction and move it on up to our numerator spot. So we're going to multiply the two fractions. 3 times 5 equals 15. 7 times 1 equals 7. Divided by that big 1 that we just get rid of. We don't even have to worry about it. And we have 15/7. So inverting and multiplying is a result of not wanting to divide two fractions by each other and having a much easier time dividing one into a fraction. And that's my teacher project.